So let's talk about grafting today, which is a different form of asexual propagation. So we've done cuttings, we have done division, and then we have done also root cuttings as well. And so grafting is going to be the next method, and it's going to be a little bit more complicated. It's going to be require a little bit more artistic and a little bit more uh, practice. But the result could be something that is very, very nice. And so let me share my screen so that you can see some of the examples that can be achieved to what we are going to be calling grafting and training. And from the image here, where a group of students and I took a field trip to see Barron's brother nursery. They own one of the largest tree nursery in Southern California. And you can see leading up to their area, you have sycamore trees that have been trained. Branches have started to be shaped into the circle. And what they wanted to achieve was a tunnel that will guide your eye onto their logo or their family logo uh, from when you start driving in, and that is what they have achieved. Looking at it from an angle or from a different view, that's how they're going to look. So these are sycamores where they have taken branches, they have trained them, and on top they will tie them. Eventually, the branches will fuse with one another and will remain like that for the rest of their life. Here is something a little bit different. This is a type of cedar, and we have a grafting where they have taken some of the weeping type cedars and they have grafted them onto a standard tree. And so this would be a method that is used for a lot of the weeping plants. That would be a natural mutation. And the only way to keep them like that or to create a fountain-like effect on them is by grafting them. Engrafting is going to be done for a lot of the ornamentals. It's going to be done primarily for a lot of the different types of fruit trees that are going to be found out in the horticulture trade. And here is a horticulture show in China. And here we see probably the extreme of what can be achieved through grafting and training. So there are several trees. These are all crepe myrtle, and they begin to shape them and train them, and they will tie them to keep them secure for a certain amount of time until the plants develop the woodiness. And then as the branches that are kind of held together grow onto one another, they will then fuse and become a single stem. And so this is something very nice that has been achieved. They also done some kind of wall or tunnel. These are deciduous right now, but later on, when they begin to leaf out, there would be a canopy above or some foliage and maybe even some flowers. And when we look at them a little bit closer, you see the areas that are still not fused, so they have tied them, and some of the areas where they have already taken the ties or the ties have corroded. And now the stems are permanently fused. They have created a nice pillar, an entryways, and or some also some interesting vases or vase-like shapes, and even some animals. So animals, in this case, a horse. Here is the fusion of 60 units, meaning 60 different plants, trained and shaped to look into one, and eventually they'll grow into one another. Or also, here's a pig, also about 60 units fused into one, creating that shape and the form. And here's the center display, which is a very large tree, also started from several different ones, eventually shape and train. So this is not something that you're going to achieve uh, in a couple of years. This is a very long time for them to achieve something like this. So you need to be patient if you're going to be doing some kind of artistic shape. A little bit closer to home, we have some of the cactus or the cacti that you may find at the local garden center, and they are grafted. So there is a selection that has the yellow or the orange color, and those are grafted into a climbing cactus that is going to be green, and it creates more of an artistic, more of a gift, or something interesting to look at. So there's a yellow, and here's the red. They have taken the climbing cactus, they have rooted that, and then to that, onto the top, they have grafted this other individual. And so, what is very important for you to understand with grafting is going to be the vascular system. The vascular system, which is made of the xylem and the phloem, the xylem that is responsible for moving water from the soil to the roots into the plant and eventually to the leaves or wherever they need the water, and the phloem, which is responsible for moving the carbohydrates or the sap, the sugar from the leaves to wherever else they need it or wherever they were stored from. And so the vascular system is going to be the key for ensuring that grafting is a successful method of propagation. And so what is going to happen is that we are going to take two different plants, two different genetically individuals that are compatible. Compatible meaning that they are going to be close to one another. The best example would be a citrus. You can graft all kinds of citrus, lemon, limes, oranges, mandarins, grapefruits into one single rootstock, which in most cases would be a sour orange. And so citrus, they're all in the same genus, they can be grafted onto one single plant. Or the genus Prunus, which is going to be the plums, peaches, and apricots, they can also be grafted. So very closely related plants are compatible and they will be able to be grafted onto one another. And so when we are going to be looking at grafting, it is important for you to know the two words. The most important one is going to be the stalk. The stalk, or often referred to as the rootstock, this would be the lower portion of the plant. This is going to be a rootstock that is going to be selected for specific qualities. It may be resistant to some of the diseases. It may bring some drought tolerance. It could also bring some dwarfness or control of some of the heights. Or it's just a lot more efficient in gathering resources from the soil. And so the rootstock or the stock is selected for specific qualities. And on top of the rootstock, we are going to insert what is known as the scion. The scion is going to be the top portion. And the top portion is going to be selected for specific qualities. If this were roses, this could be the specific variety, like Mr. Lincoln. If this was a avocado, this would be the Hass avocado or any of the other avocados that are being grown. If this would be a citrus, this would be the Valencia or the navel orange that you would be putting onto the rootstock. And so the scion, the top portion, the stalk or the rootstock would be the lower portion. So the two individuals are then placed together, and the vascular system between the scion and the stalk needs to match, needs to meet. And when they meet, they will then begin to share resources. There's going to be some healing tissue, and eventually the two branches, the two plants will fuse with one another and behave as one. And on the right side, we have with pink the rootstock for this plant. And we can see where there is some of the healing tissue, as well as in a little bit lighter green, we have the scion or the top portion. Here are some spurges where they have taken just a crested mutated individual that instead of having a round stem is going to be flat. So they have taken this crested individual and they have grafted it onto a round spurge, creating somewhat of a fan shape. So this is also available at many of the garden centers around here. So it's just nothing more than creating a weird shape, weird pattern. They will be more expensive because it is going to take some work to develop and care for these plants as they are healing and eventually becoming one. And then we also have here an example of another mutated. This is a monstrose, nothing more than a mutation, a grotesque growth on a plant. And so some people find that extremely attractive or desirable. And so this mutated form is grafted onto a regular, and so it creates something interesting and something new. Grafting can be done anywhere, and as long as the vascular system is connected. And I keep mentioning that because that is the secret. So you can do it either on the stem, you can do it on any of the branches, and even some of the roots. So the roots can also be grafted. And so when we look on the right, we're going to see several drawings of different types of grafting. Whenever possible, the rootstock and the scion should have the same diameter. That makes it very easy, or a lot easier for us to connect the vascular system. But if you were to be dealing with the girth of the branches that are going to be different, then you need to make sure that you locate the vascular system and that you connect the two. And so here's where we have the scion, which is going to be thinner than the stock, which is number 2. And so it's showing you where you would put that scion or connect it to the stock, so that this vascular system here represented in the dotted lines is going to match with the vascular system of the stock that is also going to be represented by the dotted line. So that is 1. And then 3 and 4 is a different view or a different plant. Once again, different girth, vascular system. So you see where you would put them. And then number 5 is showing you the back view, where you would see the vascular system perfectly connected between the two different plants. And then 6 and 7 will have a different form or a different propagation method. So here's where they would create a cut and they will insert a twig or a small piece. But once again, represented in the dotted lines is the vascular system that will need to connect. And here in number 8 is showing you when it was placed. And number 9, it will be showing you the top view, showing you the connection between the two vascular systems. So as long as the vascular system is connected, that it gives us a very good chance of having a successful graft. So graft can be done anywhere. So here is just an example of what is going to happen. So here's kind of what happened with some of those designs from the Chinese horticulture show. So branches tied together as the girth continued to increase on those branches, they will eventually begin to fuse. They will begin to fuse, and then they'll begin to share some of the resources as the girth keeps getting even bigger and bigger and bigger or thicker. They will eventually begin to become one single branch until you have a complete fusion where the two vascular system or the two branches will be now behaving as one. So this is what we want to intend. So there's different types of grafting. There is no one way that is better. Most different types of or different nurseries will have their preferred methods, or depending on the situation, you may want to be flexible and use one over the other. So here we have the splice or approach graft, where you can take two plants, could be in the ground, could be in a container, and bring them into close proximity. Uh, Make a cut on the bark to expose the vascular system, and then connect the two individuals. The two individuals will then, uh, ensuring that the vascular system is going to connect it, will then heal and become one. Or if you wanted to graft a smaller plant onto an existing one or one that's already in the ground, you can bring it in a container and then just approach and tie it. So that is one method. At the bottom, we have a seedling approach graft where you can have a baby plant also grafted onto uh, a larger plant, and that could give you something different. So The rootstock can be obtained through any variety of propagation methods. It could be seeds. For avocados, the rootstock would be a fuerte avocado, so they grow a bunch of seedlings that were never meant to be productive, any producing any fruit, and they will use that as to graft all of their haws. For citrus, they will use the same. For other plants, they might use either cuttings or root cuttings or any of the variety of methods of propagating plants that we have seen in class. They can all produce rootstock as well. And the cyan would be the selected form. So here's where we have the tongue approach. So the tongue uh, giving you a piece of the stem so that the two individuals will wedge on one another and kind of secure each other. And so they expose the vascular system that connects. And so that's going to help in ensuring that the vascular system does not separate, because that is also very important. You have to secure the two branches so that the vascular system does not separate, because if it separates, it's not going to work. And on the top right, we have the runners from strawberries that can also be grafted. So yes, there is some grafting done in strawberries. Or here's the tongue approach grafting with cucumbers or watermelons. They can also be grafted through this method. So once they have welded together or fused, now you can remove the unwanted one and also the stalk from the other and or the root. And now that just becomes one single plant. We also have bark. Remember, the vascular system is going to be found below the bark. So on many plants or trees that the bark can peel very easily, all you gotta do is just make a slit cut to open up the bark, and then you insert the stem from the desirable plant or the scion. And as long as you expose the vascular system, keep it together, that's going to be important. Or if all you got is just a piece of plant and you wanted to graft it, again, depends on the situation. You can keep the plant, the cutting long enough in a bottle of water until it is firmly secure and welded onto whatever you want to graft it on. So bottle grafting, that's also out there. Here's the cleft grafting right here, where they did an undercut, and then they're going to insert uh, the scion right there. And here's what that can be used for what is known as root, oh, sorry, uh, uh, tunneling or bridge grafting for saving trees that may have had some injuries. So that can be used for that. Or we have the bark arching here as an example, where they just peel back the bark, and in this case, they will weld together some of those uh, the the scion and the stock. And so I mentioned the bridge grafting. So here we have an example of a plant that probably, as time went by, it rejected its own graft. It happens. And so they can then find something that is going to be compatible with both of them. And so you would graft it to the root that is still actively growing, or the rootstock, and then bridge it and also graft it to the scion that's on top. And so now this bridge is going to be responsible for providing the water to the scion and or providing the vitamins and minerals to the rootstock. So bridge grafting is done. So here's a curve graft, and this is often used by a lot of the orchards when they are going to replace or change the variety of cherries, peaches, or apricots that they are going to be producing. So there's no need to start with a new plant. If you're already growing cherries, that big tree can serve as a very good rootstock. So they can then decapitate, for a lack of a description, the plant, and then use the remaining stem to then graft the new selected varieties of cherries, plums, peaches, or apricots, or apples onto the existing old rootstock that was already there. So that is going to be very important for orchards so that they don't have to start with a very small plant. And this already has a very well established rootstock that will begin to feed the new uh, scion, and it's going to be able to bear fruit a lot earlier. And so here's what will happen. So here's the scion being inserted into the graft and into the uh, rootstock. So here's the splice graft. When you take the scion and the rootstock, you make identical cuts, and then you put them together, tie them up, and that will graft. Or the whip tongue graft, where you once again you leave a tiny portion that will help in securing and keeping the two together, and then you can tie them up. And here's just different views for this. And also sometimes if the scion is very small or very uh, the girth is not too thick, then you can put more than one onto a larger or thicker stem or thicker rootstock. So just a couple of different examples. Again, double tongue graft, and there is no specific method. You ask different people, they each have their own preferred method. Or the saddle graft, where you expose the vascular system, and then you then insert the scion, and it just sits perfectly on top of the rootstock, and then you tie it and secure it. So here's the bark graft. So just peel back the bark, insert the scion. So here's where they made the cut, and then just pull back the bark if that's possible uh, for that. And or the wedge or cleft graft, which is where you cut down on the stem and then you insert the scion on top of that and then secure it, as you can see with this tomato plant. There is also going to be budding as a method of grafting, and budding is just that. They will take just one single bud that will have the ability of generating an entire plant. And so this is going to be important because sometimes the grower may have just a few branches. And so when you're doing the standard method of propagation or grafting, sorry, you may have to use a piece of a branch that will have several buds. So you're sacrificing a few of them. But when you're doing budding, you ensure that every single bud will become a new tree, or if material, the scion is not as readily available or it's kind of rare, then that ensures that you're going to be building up your stock pretty soon or your plant material. And so for budding, you would then first do the bark cut. So you will make it in the shape of a T here, and then slit down. So that is going to pull back the bark from the stem. And then you would then insert a single bud or a chip. You would chip kind of the bud from the stalk, the scion, sorry, and then you will insert it into the bark and then tie it, secure it, so that you can have the bud here embedded within or underneath the bark, and that will eventually grow out and become a new plant. And so here is the chip bud. So you can see where they can remove an existing bud from the rootstock, and then it gets replaced by the new, exactly the same form shape chip from the now preferred scion. So that's where they would cut it. Or the patch bud, once again, they will take the bud from the existing, in this case in a rectangular form, and then transfer over to a different plant in the same form shape, and that will then take over. Now there is something known as double working or double graft that is important. So this is going to be done for plants where the scion and the rootstock may not be compatible. So we need something in the middle, something that is compatible with the scion and something that is compatible with the rootstock. And so we're going to use a third plant that is going to serve as an interstock in between. So we are going to graft the rootstock to that inner stock, and then we're going to graft the scion onto that inner stock. And so this would be the midpoint where it's going to allow for this to occur. Now we can also use this to create different forms or patterns or shapes as well. But it's often used when whatever scion and whatever rootstock may not be compatible, but you still need to graft them. So that's what's going to be. And so you may have seen some of this tree roses that are available in your local garden center. So this is the perfect example of one of those inner stalks. So we have at the bottom, we have one graft, and that what you see here is known as the graft union. And so below that, that is the rootstock. That is one plant. And above that, in a little bit lighter gray color, we have the interstock, and on top of the interstock, we have the selected variety. I think this is Double Delight Rose that was planted. So we have three different roses. The middle one is going to be a climbing rose. And so that's how they achieve those tree roses by doing a double grafting. And so, regarding of whether you use budding or grafting, the outcome is going to be the same, depending on how much material may be available. So we have here an example of a plant. We can start with A. A plant is then going to be grafted. We're going to decapitate it, and then we're going to graft one single plant. Eventually, when the graft is done, the top portion is going to have to be removed, and then that branch is then going to be encouraged, and that will become the new plant. Or here, we can also bud it, and it's going to bud. The bud is going to grow into a brand new branch, and that branch is going to be encouraged, and that's going to give us the final plant, which is going to be that individual. Or here's just the regular grafting, different forms, different shapes, or the double grafting that would also give us that same plant. And so this, although working together, there still might be two genetically different individuals. So the top portion will always give us that Valencia orange that is very sweet and seedless. And the bottom one is always going to give us that sour orange. So the genetic of the plant is not changing, even though the plants are sharing the vascular system with one another. The other thing that is very important for you to know regarding grafting is that some nurseries will do what is known as a top graft. So here is a ornamental cherry, and so we have the rootstock that is grown to a certain height, and then at certain height, specific height, they're going to then graft the desirable cherry tree, cherry plant, cherry blossom tree. So this is a high graft. It's very high, several feet off of the ground. And you can see the graft union, and you can see a very different color between the scion and the rootstock. Or there's going to be a low graft, and the low graft is just going to be a couple of inches from the ground. So here's the soil, and so here is the graft union where the two individuals are meeting. And so sometimes it's easier to graft one or the other, or sometimes for creating a shape form, that's what they're going to be using. So make sure that if you're going to be buying or looking for graft, that you either say low graft or high graft, depending on what's happening. Okay, so here's just general tools that we need to use. Alcohol is important to disinfect the tools, disinfect the plant materials. We need a little bit of parafilm to secure the stock if it's not too thick. We can use a grafting wax or a grafting seal. Those could be quite messy, but some people like them, some people don't. And then just a knife, a pen knife, or a pocket knife, or a grafting knife if you wanted to invest the money, because there are some knives that are sold specifically for grafting. And so when we're going to be doing the stock, here's where we are going to decapitate the plant. decapitate the plant. It's ready for receive the scion. The scion is going to be at the bottom. And the scion, we're going to expose the vascular system by making diagonal cuts that exposes the vascular system. And on this rootstock, we're going to make a nice cut through the center. And we are going to match the vascular system. That means we are going to put them almost end to end, or so that the two the bark is going to meet. And then we're going to wrap it and secure it. And in time, we can see here when it was done successful, two different graphs here. So we have the stock that I shown you before with the healing tissue. And here is a different form where you have a little bit in the pink. That's the rootstock. And you see the scion already very well welded together. Here's where I did three different graphs. Two of them took, one of them did not. So that gives us a chance to try it again later. But you can see two very successful ones there that were good. Here's some citrus trees that are grafted. I mentioned those are also grafted or budded. And when you are going to be dealing with plants that are grafted, it is very, very important to keep an eye out for them, because one of the most common questions that I get from people is that for many years they had a very sweet orange or citrus, and a couple of years later it became very sour, and they do not know why, and they want to know what fertilizers do they need to use. The problem is that in the case of citrus, the rootstock is a sour orange. And so it is not uncommon for the rootstock to want to send out their own shoots. So they're going to fight, for a lack of a better description, the graft. Or if there's a shoot, a bud that happens to be growing out of the ground as a sucker or coming from the rootstock, that needs to be removed immediately or as soon as possible, because that is going to be a lot more stronger, more robust, and in time it will kill the grafted individual. And so here in a neighborhood, I spotted this citrus, and you notice several differences here. We have half of the plant that is very nice and green, and then half of the plant that is not doing very well, and it's kind of yellowish. So one of them is the graft, and one of them is coming from the rootstock. And so people eventually trim him and prune it and make it look as an individual, when in fact it is going to eventually kill that sweet citrus that you purchase it. And then when I looked a little bit closer, we can see a very different fruit. So here is probably what looks like a kumquat or a calamansi, and here's a sour orange. So the fruit is very different from both. So they're coming from the two different plants. Here are some elm trees. In this, you can see a very big difference in the rootstock and the scion. So the scion is below. And here's the example. So these are purple leaf plum. They're also grafted. And if you notice, the shoots that are coming from below are green, whereas the one from above, which is the desirable color, are purple. And so the green shoots that are coming below the graft union need to be removed. And that is what happened with the orange. So the orange, the sour oranges were coming from plants that were allowed to grow from the rootstock, and that's not good. And here is exactly that. So we have the graft, we have the rootstock, and then on the left, we have a beautiful, young, robust shoot coming from below the graft. The graft union is right here. So this is where the scion was connected to the plant. This wound is from the original top portion of the rootstock that was removed once the graft took. And a very robust, strong young shoot coming from below the graft union. So anything below the graft union needs to be removed as soon as possible. Uh, with grafting, there is the possibility of having a three in one, so three different fruits in one single rootstock. Not too long ago, there was a viral photograph of a person that did uh, 60, I think 60 different varieties of plums onto one single rootstock. It has taken many years, but yes, you can grow different types of plums, peaches, and apricots into one single rootstock. Or in this case, are four different plums grown into one single rootstock. So this is the four in one. So the white labels are telling me the different plum varieties, and they also have a different color. And then the pink label is telling me the information of the rootstock, so the type of rootstock that they're grafted on. I mentioned the weeping habits. So this is a weeping mulberry that the weeping shape form is achieved by the grafting. So a form that will normally weep grafted onto a regular stock. And so with that, I will end the presentation. Have a great day and take care. Bye bye.